Hey there, engineers. Today, I'm diving into the fascinating world of pressure die casting. Whether you're a seasoned professional or just getting started, I promise you'll find this process as captivating as I do. So let's get right into it. First off, what is pressure die casting? Essentially, it's a manufacturing process used to produce complex metal parts with high precision. The magic happens when molten metal is injected into a mold cavity under high pressure. Think of it like baking a cake, but instead of batter, you're using molten metal. And instead of a cake mold, you have a sturdy steel mold. The process kicks off with the preparation of the die or mold. These molds are made from steel and designed to withstand the extreme pressures and temperatures involved. The molds are precision engineered to ensure that every part produced is identical and meets strict quality standards. Now let's talk about the heart of the process. The injection. Molten metal, usually aluminum, zinc or magnesium, is heated to its melting point. Once it's molten, it's forced into the mold cavity at high pressure using a plunger. This high pressure is key because it ensures that the metal fills every nook and cranny of the mold, capturing even the finest details. Once the mold is filled, the metal cools and solidifies almost instantly. This rapid cooling is another critical aspect of die casting because it helps maintain the integrity and accuracy of the final part. After the metal has solidified, the mold opens and the newly formed part is ejected. The cycle then repeats, allowing for the mass production of high-quality uniform parts. It's efficient, it's precise, and it's incredibly cool to watch. But hold on, there's more. Die casting isn't just about creating parts quickly, it's also about creating parts that are incredibly strong and durable. The high-pressure injection and rapid cooling result in a dense, fine-grained structure that enhances the mechanical properties of the metal. This makes die-cast parts ideal for applications where strength and reliability are paramount. Of course, like any manufacturing process, pressure die casting has its challenges. Issues like porosity, where gas gets trapped in the metal, can affect the quality of the final product, but with advanced techniques and careful control, these challenges can be effectively managed. And there you have it, pressure die casting in a nutshell. It's a brilliant melding of engineering, physics, and a bit of artistry. Next time you see a complex metal part, you'll know just how much precision and expertise went into making it. Thanks for tuning in, and don't forget to like, subscribe, and hit the bell icon for more engineering insights and explanations. Catch you in the next one.